This is a recast of the 9100-word piece. Walter Pitts, the pioneer who shaped modern AI, from AI VIPs. Let's listen in.
The article talks about Walter Pitts, an underappreciated figure in the history of artificial intelligence. Pitts, along with Warren McCulloch, laid the groundwork for neural networks, which are a cornerstone of modern AI systems. At the age of just 20, Pitts co-authored a paper that introduced the McCulloch-Pitts model of the neuron. This work bridged the gap between biological neurons and computational models, marking one of the first steps in conceptualizing how machines could simulate human cognitive processes.
Pitts' work, despite his relatively short life and obscurity in the popular narrative of AI, set the stage for many developments that would later fuel the AI revolution. His collaboration with McCulloch was not only a technical breakthrough but a visionary leap that helped birth the concept of neural computation. In many ways, Pitts can be seen as a bridge between early cybernetics and present-day advances in AI, deep learning, and neural networks.
Let's look into his early life. Walter Pitts was born in 1923 into a working-class family. Despite his brilliance, he dropped out of school at 15 due to a challenging environment at home and dissatisfaction with traditional schooling. But this didn't signal an end to his intellectual journey. He was a self-taught prodigy who immersed himself in advanced mathematical texts and logic.
One of Pitts' main influences was Bertrand Russell, a philosopher whose contributions to symbolic logic significantly shaped modern mathematical thought. At the age of 12, Pitts discovered Russell's Principia Mathematica, which fueled his passion for logic and abstract thought. This text had a profound impact on Pitts and helped him understand how complex problems could be reduced into logical and mathematical forms.
His intellectual journey took a critical turn when he met Warren McCulloch, a neurophysiologist, during a visit to the University of Chicago in the early 1940s. Their meeting marked the beginning of one of the most consequential partnerships in the history of artificial intelligence. McCulloch immediately recognized Pitts' intellectual potential and invited him to collaborate on creating a mathematical model that could explain how the brain processes information.
Their collaboration culminated in the 1943 publication of A Logical Calculus of the Ideas Immanent in Nervous Activity, which laid the foundation for modern neural networks. The result was the McCulloch-Pitts neuron, a theoretical model that treated neurons as binary units capable of either firing or not, much like logic gates in a computer.
Apart from his collaboration with McCulloch, Pitts also worked with Norbert Wiener, one of the pioneers of cybernetics. Wiener was developing ideas about how control systems and feedback mechanisms could be applied to biological and mechanical systems.
Their partnership expanded upon Pitts' earlier work with McCulloch, particularly focusing on how feedback mechanisms might be applied to neural networks and how the brain could learn from past experiences and adjust future behavior accordingly.
Despite his significant contributions to AI and neural computation, Walter Pitts' life and career were marked by personal struggles. After a falling out with his mentor and close collaborator Norbert Wiener, Pitts withdrew from active research and became increasingly isolated. He stopped publishing and retreated from the intellectual community.
Pitts' later years were marked by a deep sense of despair and a tragic decline that cut short the career of one of the most brilliant minds of his time. He passed away in 1969 at the age of 46 due to complications from years of heavy drinking and declining health.
Despite the challenges he faced, Walter Pitts' legacy lives on in the field of artificial intelligence. His work on neural networks laid the groundwork for key innovations such as the perceptron and modern deep learning, both of which continue to drive AI research today.
His interdisciplinary approach continues to influence not only AI but also fields like cognitive science, systems theory, and neuroscience. His conceptualization of intelligence as a computational process continues to inform how we think about the brain and artificial intelligence, bridging the gap between biological and machine-based cognition.
That's it for today.